Hello everyone, today in this video we'll be discussing the PYQs of DBMS. So this video is just for the revision purpose. If you want detailed answers, you please see the document which I have provided in the last link in the description box. In that the detailed answers explanation is there. Okay, this is just for the revision purpose, like just before exam. If you want to just cover what are the important topics, watch this video. Okay, I'll be going through each topic very briefly, like one or two sentences I will be telling what you need to remember. Okay, so let's get started, and if you like this video, hit the like button and don't forget to subscribe to my channel. Okay, so explain the main characteristics is the first question. There are 4 characteristics. The first one is the self-describing nature. That means the DBMS has manual, and second is the programs, data, and the data abstraction is being supported in DBMS, and it supports multiple views and multiple users can access it. Okay, so these are the 4 points you have to write and explain each point, like 5 or 10 points you need to write for each line. Okay, and the next one is list the advantages and disadvantages. You can go through it, like it's redundancy is reduced and backup and recovery is there. So there are many of them. Just remember 5 or just remember 5 points. Okay, and explain it in your own words. Next one is the disadvantages. It like it's sometimes cause unnecessary overheads, and it has high initial investment, and it has the generality for providing and defining the processing. It costs a lot. So there is a cost. The major disadvantage is that the cost issue. Okay, so that was the disadvantages and advantages. The next one is the with a neat block diagram explain the architecture of typical DBMS. This is the diagram which you have to make. There are 3 parts in it. The first part is the database system. This includes all of these. Okay, and you start from the user. User will access the application programs, which is the SQL terminal, and from there the software processing happens, that is the DBMS software, and after that the database is accessed. Okay, so this is the database for storing the metadata, and this for the data. Okay, and you just have to explain what are the different components in that. Moving on to the next question, we have what are the responsibilities of DBA and database designers. DBA is the one who administrates, okay, like oversees and manages the resources, authorizes and means coordinating and monitoring its use. Database designer is the one who makes the organization, like how is the data to be organized, which is the data type to be used, and so on. Okay. Next one is with a neat diagram explain the component modules of DBMS and their interactions. So this is what you have to make, and we'll be starting from here. It's pretty simple. DBS staff, casual users, application program, and parametric users. These are the different types of users. Okay, these are this is the one who will be designing the database, and these are the users. There are 3 types: parametric, application, and the casual users. So let's see what is the difference between each of these. Okay, so first we'll see the difference. Database staff, you know, it's the database administration staff members. Casual users means occasional users. Application programmers means those who design the application. Parametric users means those who repeat the same sequences frequently, like in a bank. Okay, if you go to the bank, you will be making an account in a bank. At that time, some other steps to be followed, right? If the step to be followed every time, that can be stored somewhere and that can be used. So those are the parametric users. Okay, so after you have done that, let's see what is there in each of these. Database staff use DDL statements and DDL comparer. Data definition. What does the database staff do? They will first define the language, then they will do the things, right? So DDL statements and DDL compiler. Privilege command system, prioritized commands. Okay. Coming to casual users, there will be an interface by using which you will query it, and the query will be optimized. Application program is also the same thing. It will be compiled, and it will be like pre-compilation and the actual compilation. And the parametric users also the same thing. They will be compiled transactions before only, and those will be sent to the execution. And that was about the users part. And coming to the software part, these are the database storages, and here's the runtime processing happen, and the stored data manager, concurrency, and backup control. All of this will be interconnected. Okay, so you have to make the diagram and explain what are these. You can go through it. It's pretty simple. If you want more information, I have explained in the module 1 video of DBMS. Okay, the next one is about write a short note on the 3 schema architecture, very important question. And why do we need mapping between schema levels? In the 3 schema architecture, there are 3 levels here. First is the external level where the users will be there, and the second is the conceptual level where the software things will happen, and the third one is the internal level. Internal level will be directly connected to the stored database, and based on that you just have to write 3 points for each of these. Okay, and second is why do we need mapping between different levels? See, you have to transfer the data from one level to different level continuously, so therefore the mapping is needed to in order to make sure that the data is sent but the format is changed. Okay, the next question is explain the different types of symbols that occur in ER model with the example. So these are the symbols and their meanings is written here, so you can go through it, and you should make these diagrams and write what are the meaning of it. Okay, next one is explain the different attributes that occur in the ER model. What are the attributes? Firstly, it can be composite or simple. Composite means one of the attribute can have different attributes in it. Okay, like address will have street address, city, and state, zip address, and so on. Okay, and simple means just a simple value like age of a person. The next one is about the single valued versus multivalued. That's pretty simple by its name itself. What is stored and derived? This is the inbuilt, and this is the user defined. Null values is like sometimes you have to store the null values in the table. That's what they are telling here. Complex attributes means some of the attributes will be like inside the attribute there will be many attributes. Like for example, address phone. There will be phone, and inside the phone there will be area code and the sector and all, city and those things. Okay, so this is the complex attribute. So these are the 5 attributes of the that occur in the ER model, and after that we need to know how to make the ER diagram for the means anything they can have, like bank or college or university or office. Okay, so these are the 4 main things, but the bank one is repeated most number of times. So let's see how to make the bank one. This is also discussed in the theory video. If you want more information, go to that video. Here just you have to make that what is in the bank, like there will be a customer, and banks are identified by name, address, and main office, and so on. Okay, and to make this diagram, first start from here. The branch will be here, and first start from bank. Okay, bank has how many branches? N number of branches, and each branch will offer loans and maintain an account. And offer loan for whom? For the customer, and maintain account for whom? The customer. So this will be interconnected here, and the rest of the things are just same. Like account will have account number, account type, balance, and here we'll have bank name, bank code, address, and customer will have the ID, name, and phone, and so on. Okay, like that you have to make here. And what are these things that numbers will be discussing now? We will be first defining, after you have made the diagram, we will be defining each of these entities present here. After that you will be saying what is the relationship between them. Means one bank has how many branches? N number of branches, so 1:n. Like that you will be seeing for each of the relations connected and writing the appropriate relation. Okay, so that's all for module 1. Let's move to module 2. Here we have the characteristics of relations. So there are 4 characteristics. Ordering of tuples in a relation means the order of the tuples is not important. The first row can be here or here, it doesn't matter. Second is the ordering of the values within the tuple. So if a tuple is here, I have 2 things here, name and age. Age can come here and name can come here also, given that with age int is there and with name string is there. Okay, and values and nulls in the tuples, either it can be filled with values or it can be filled with nulls if it's required. Like for example, a student's database is there, in that office phone number is there. So a student's office phone number does not apply to the student, right? So they will be filling as null. That's what they are told here, and interpretation is the meaning of relation. Okay, write these 4 characteristics and explain each one by one. Okay. Next one is the important question, which is the 3 types of constraints. So 3 types of constraints are implicit constraint, which are inbuilt in the inherent in the data model, like primary key cannot be null. Explicit means we are specifying the constraints, and the last one is application based. Okay, means the salary of the employee cannot be greater than the salary of the manager. Okay, like that we are specifying it. Next one is the insert, delete, and update operations. Here the insert operation, what are the anomalies that can happen? Domain constraints, if you are in the phone number, you have to enter the phone number here, but you are entering the name. That is a domain constraint, different domains. Next is the key constraints. The primary key cannot be null and it cannot be duplicate also. Entity integrity means the entity is getting deferred, and referential integrity means it is referring to a table which is not yet existing. Okay, so that's the 4 insertion operation constraints. Deletion operation means if you are trying to delete some value which is already referring to some other value, you cannot delete it. Okay, that's the deletion constraint. Update constraint means just what is discussed in the insertion and deletion, because updation is nothing but the modification. That means deleting something and inserting something. So that remains same for the updation also. The next important question is about these 4 algebraic operations: a union, intersection, minus, and Cartesian product. You know the meanings between them. Just make the table here. If you want to find out the union, just write what are all the rows present here without any duplicates. Okay, that will be the answer. And intersection means what are the common rows, that you will note down. What is the difference means if you are doing this this table minus this table. In this table, remove all those present here. For example, if I have like Ramesh is here, Ramesh is here, so I have to remove this one. In this table, finally, no row of this table should be there. That's what means T1 minus T2. Cartesian product means just the combination of each of these, means with this row, what is the combination with this one, this one, this one, and this one, like that for each row we will be doing. That is the Cartesian product. The final answer will be the Cartesian product. And the next one is the join operation, a very important one. In join operation, we have a few types, like equijoin. Equijoin will happen when there is like a similar name, like roll number and S number is same, like similar, right? The name is not same but it's similar, so it will be joined. Joined means what? The 2 tables will be in a single table. Okay. Natural join means it will join when the name is same, like roll number here and here, so name and class will be joined after roll number. Next one is the outer join and inner join. If you are joining two tables here, okay, if you are joining two tables here, but here you have 3 rows, here you have 5 rows. So 3 rows will be joined here in the outer join, and rest 2 will be written as null here. That is the outer join. But in the inner join, null will not be written. Okay, that's the only difference. And right outer join, left outer join, and full outer join is nothing but you are keeping the left values in the left join and the right values in the right join. And full outer join means you are keeping both values in the join operation. Okay. Next one is the explain with example steps to convert the ER diagram into schema diagram. This also I have explained in very detail in the theory video. Go and watch that if you need more information in this regard. And basically what you have to do is you have to just see which is the strong entity types, which are just in a single rectangle. After you have noted down that, write the attributes of it. Attribute means what is in the circle here. After that, see here the name is having a composite attribute because it has multiple attributes here. So instead of name, what you will write is the direct thing like f name, m name and l name. That is the first thing. The second thing is mapping of the weak entity types. Where is the weak entity type? Here we have the weak entity dependent. So how you will map that is, firstly you will be writing the dependent here, and from which table it is derived? From the department table as well as the employee table. So that marking we will be making. The third step is mapping of 1:1 relationship. In 1:1 relationship, which has the means the dependencies that we will be marking in the diagram. And for 1:n relationship, like what you will be doing is you will be adding a new thing. Okay, for example, one thing I will explain: department to employee. Each department has n number of employees. So for each employee ID card, they should be written right in which department you belong to. So in employee, what should be written? Department number. So that's what I have included here. The department number is included, and that should be pointing to department number. The same thing has to be done for all the 1:n relationships. Okay, and m:1 relationship, it's a exceptional case. Here what will happen is, where is m:1? M employees are working for n projects. So what you will make is, in that case you will create a new table works on. In that R's will also be the attribute. Along with that, what is the primary key of employee, primary key of project, both will be written. Okay, so works on table will be created here. Works on table will have the R's, which is the attribute of works on, and SSN and P number are the primary keys of employee as well as the project. Okay, so that's what you have to do in m:1. And multivalued attributes, if you have multivalued attribute, that means in the location here, as you can see, location is in double circle. That means it has multiple values, like some of the departments might be in US, UK or India. So there are multiple values for each location, right? So for that you will be creating a new table here, department location, and the department number will be there along with that location. So for UK, US, India, there will be 3 rows in the column, one for India, one for US, one for UK. Okay. And mapping of any array relationship, if there are more than 2 types of relationship, at that time we will create a new table supply, and that will be connected with the part, project and supplier. Each of these will be having a new table. Okay, so that's what you have to do, the 7 steps to convert. And what are the basic data type available? These are the data type: numeric, character, bit string, boolean, date, time, and time with time zone. Okay. With examples, explain the basic constraint that can be specified. So there are key and referential integrity constraint, and restrictions such as not null or default, and constraints such as check constraints. Okay. Explain the following commands: insert, delete, update, and alter. So these are the syntaxes you have to write, and explain what are the fields and what will be the changes happening after the insertion of the command. Okay, it's all things I have discussed very detailed in the module video. Okay, so that's why I'm going very fast here. Okay. So that's all important things in the module 2. Coming to module 3, we have these queries here, like nested queries, join operations. So let's discuss briefly what are these things. Here the nested query means a query inside a query. This outer query, this is the inner query, that is known as nested query. Join operation we have already discussed, like joining 2 tables. Aggregate functions means sum, min, max, count and average. Grouping means grouping the values according to the what is the group, like color or employee department and so on. Okay. And views means cutting the big table into a small table and storing it as a separate table. Okay. Assertion and trigger means assertion is used for checking, trigger is used for doing what operation when the check is successful. So these are the syntaxes and example for assertion and trigger. And schema change, like alter and drop, that also you need to know. So those were the things which they ask mostly in the syntax part. And coming to what is dynamic SQL and how it is different from embedded SQL. In dynamic SQL, you will be what you will be having is the statements will be created at the moment, but in embedded SQL it will be already specified. That's the only difference. and you just have to explain that using an example. And coming to the next question, cursor and its properties. What is cursor? We can move the cursor to any place in the computer, right? That's what the cursor is. If you have a big document here of SQL, wherever you want, the cursor will go and you can perform the operation. For that, you have to open the cursor, fetch the next row, move the cursor, and after the operation is done, close it. So here's an example where I am fetching the sinfo and means sname and s8 from the SQL database here. So here the name and sh information is there. By using a cursor, I am fetching the values into cursor sname and cursor age. Okay, so this will point to here, and that means value will be fetched here and stored in a new variable. This value also will be fetched and stored in a new variable. That's why cursor is used. Wherever you want to go, you can go and fetch the values. Okay. So these are the properties of cursor. You just have to write the syntax here and explain what are the properties, like the outer properties. It can be either read only cursor or the update only cursor, and the scroll you can have insensitive, holdable cursor, order by cursor, and so on for different purposes. Okay. After you have done that, that's all what you have to do in the cursor and its properties. Next one is what is SQLJ, how it's different from JDBC. SQLJ is used for defining the Java with SQL. Okay. For that, these are the syntaxes, like it will start from #SQL, and the way to write is there will be an iterator, and you will declare the iterator of the class, and you will be traversing through each of the line statements here, and after that you will be reading the rows and performing the changes, and after you are done, you will be closing the iterator object. Coming to JDBC, it's the Java database connectivity. It's a slightly different concept. Here you will have 4 things which you need to define: application, driver manager, driver, and data sources. Okay. And these are the steps that's also discussed in depth in the theory video, so you can watch that. And here we have the briefly explain the types of JDBC drivers with a neat diagram. So JDBC drivers are 4 types based on the network. Like the type 1 bridges will have that are not native, and type 2 bridges are for native APIs, and then next 2 are like the network bridges, and the 4th one is the data transaction via the sockets. Okay, this is for the TCP/IP, and this is for the Java sockets. Okay. Coming to stored procedure is a very important question here. What is a stored procedure? A procedure which is stored. Okay, that's all what is a stored procedure. You will be using this whenever you want to execute something. Like for example, if you want to fetch the USN of a person who has borrowed a book from the library, you will store a thing for it. This is just like a function. Okay, whenever you want to add 2 numbers, you will define a function here. You will just call the function. So stored procedure is same thing. You will write a procedure and store it. Whenever you want, you will call it. Okay, so this is the example which you have to write and explain. Okay. Draw and explain the 3-tier architecture and technology relevant to each tier. Okay, so the 3-tier architecture is as follows: presentation, middle, and data management. In presentation layer means the top layer, we are the ones who are interacting with it. So what are the languages used here? HTTP, JavaScript, and CSS. Okay. In the middle tier, the logic is defined, so C, C++, Perl, Java, and so on. And the last one is so in that middle tier also this will be there: common gateway interface, application servers, servlets, and Java server pages. In the last one, you will have the SQL MongoDB for storing the data. That's in the last tier. Okay, and these are the advantages, which is the advantages of using the 3-tier architecture. Okay. Moving on to module 4, the first important question is explain the informal design guidelines. There are 4 of them. The first one is make sure that the meaning is clear. So you can give an example where the meaning is clear of the database, and the second one is remove the redundant information. Okay, so what is the redundant information? Here if you have the D number as 5 and there are many locations for it, like 5 has 3 locations, so in that instead of having 5 3 times, we can store that in one place and we can just refer it. Okay, so that was the second one. Third one is reduce the null values. Fourth one is make sure that the spurious tuples are not generated. Okay, so for each given example. And the next question is what is normalization? Explain 1, 2, and 3 normal forms. Normalization means cleaning the database. Okay, means more organized way. And the first one is 1NF does not allow multivalued attributes. For example, if you have D location here in department and locations are 3, like 3 places, at that time what you can do is you can create a new table here. See, 3 locations are there, right? So which department does it belong to? 5, right? So what you will do, you will have a reference here for 5, this location, and this location also. And this only not the primary key, because it will violate the constraint, because repetition is there. So what we'll have is these 2 combined primary key. So these two will always be unique, and we can reference this using the department table here. Just 5 is enough. It will be referring to this one, and it will be selected among each of these. Okay. The second is the 2NF. Here we have the concept of full functional dependency. What is full functional dependency? You have two things here, and that is connected to the single thing. This is the two primary keys, and ours is connected to that. The second is ename, pname, and plocation. Here it's just the partial dependency. Why? Because ename is just dependent upon SSN. It's not dependent upon p number. That is the violation of 2NF. How can we solve this? Is if it's just dependent on this one, separate it. That's it. So here we will have just this one, and wherever it is partially dependent, make it as partially dependent. Okay, that will solve the 2NF problem. Third is the 3NF, transitive dependency. Here you can see SSN is the primary key. It's dependent on D number, and D number has two more dependencies, dname and dmanager SSN. So to solve this dependency, separate it. So you'll have till D number here, and from D number to dmanager SSN. That will solve the 3NF. Okay. Moving on, we have the algorithm to find the closure of X and F. Okay, closure of X and F means the F will have a functional dependencies here, and how many X are under closure of it. Okay, that will be finding. So your first step is to add all the X attributes in the set. After that, you will be finding out which are the functionally dependent on X. Whenever you find, add it. Keep on doing repeating until it gets over, until no more attributes are added. So what is the final answer you have? That's the closure of X. Okay. The next question is, what is functional dependency? We already discussed it should depend on the primary key, that is known as functional dependency. There are some rules known as inference rules. So these are the inference rules. Okay, reflexive, augmentation, transitive, decomposition, union, and pseudo transitive. Write these rules and explain what does this mean. Okay. Next one is, what are the problems caused by insertion, deletion, and updation anomalies? Insertion anomaly means if suppose that I am the new employee, I came into the company, but as of now I don't have any department, which department I should work on, but my data should be entered, right? That should be entered without the department information. That is the insertion anomaly. Second is, it is difficult to insert the department value for a new employee who doesn't have the department assigned. Okay, this was the first thing. Second thing is that when you add something to the new value, the proper value should be added. The mistakes can be made, right? So those are the two insertion anomalies. The second is the deletion anomaly. If suppose that I am the last person working in the chemistry department, if I leave the college, my data will be deleted here, like the number, name, age, and phone, also which department I used to work on. So if my data about the department is deleted, in the database there is no more data about the department chemistry, so that will be lost, right? So that is the deletion anomaly. Okay, and the third one is the modification anomaly. It just means that maintaining consistency while updating the values. Okay, so next is about the joint dependency and multivalued dependency. 4NF and 5NF with an example. So here, what is 4NF? In 4NF we have the repetitions here, like many times Smith is written, X, Y, and John and Anna. So what we will be doing is we will be separating this such that Smith has X, Smith has Y. Also Smith has John, Smith has Anna. So that will be in a smaller table. That is multivalued dependency, and how we will solve the 4NF. Okay. Moving on, we have the 5NF. That means the joint dependency. In that, this is the table here. This will be divided into three parts here. In three parts, Smith is dependent on bolt, and Smith is dependent on nut, and so on. Okay, so these two will be taken as separate, these two will be taken as separate, and these two will be taken as separate. So when you join these three values, you will get back the same table without the generation of spurious tuples. So some rules are there how to divide this one. So that's what the 5NF is. Okay. Moving on, we have the non-additive joining property of decomposition. Here no spurious tuple should be generated after the join operation, that is specified. Okay, so the algorithm is as follows. First we will write the input, then we have 5 steps here. So let's go through briefly what are the steps. In this, we have the first one is, what are the inputs? A relation R, decomposition, a set F of functional dependencies. So firstly, create a matrix S and assign that. In that, you will have the rows and columns for the relation R and the dependencies in the column. Okay, means rows will have the relation and the dependencies will have the column. Okay, after that, set each S of ij as B of ij. Okay, means everything will be B first, and when you find out a dependency, make it as A. Okay, so until the end, repeat it until there is no more changes to S, and if you find that all the symbols in that are A, that means its non-additive joint dependency is valid. If it has some B, it is not valid. Okay, so that's all what is explained here. In the nested for loop, you will be doing the same thing and checking each row if it's able to change to A, or if it is A, can it stay A or not. Okay, so that's what you have to explain here. And if a row is made up of only A symbols, then the decomposition has a non-additive joint property, otherwise it doesn't have. Okay. Coming to module 5, very few important topics are there, like the first one is asset properties, second is the diagram to the state transition diagram. Here 6 states are there, explain each state one by one, and what is the why is the concurrency control needed because of these problems: lost update, temporary update, incorrect summary, and unpredictable read problem. And what is two-phase locking? Very important one. Phase 1 and phase 2 expanding, shrinking. You have to make this example. You have to draw this diagram and explain it in your own words. And finally we have the timestamp ordering and no undo redo recovery algorithm. Timestamp ordering means you will be having the transactions written in the timestamps order, that is the timestamp ordering. And if you want to perform any more operations, first you will be checking the read timestamp and write timestamp of each of those separately, and then you will be performing the operation. Finally we have the no undo redo recovery algorithm. Here what will happen is, here it is the two things are there. Firstly they can ask no undo redo or undo no redo. Okay, so what is the difference is that, let me explain you in a very simple manner. What is no undo redo means, whenever you do a transaction it will not be updated to the database. Okay, this is the database, it will not be updated on the spot. Once it is confirmed it will be updated, so no need of undo, right? Because once it confirmed then only we are writing here, but redo will be there. Okay, and in the second one it is the immediate update. Immediate update means you will first have whatever the transaction happens, you will be writing here again. Whatever happens you will be writing in the table. Suppose that it goes wrong, you have to undo it. So that is undo no redo. Okay, so those two names are, the first one is the immediate update and second is the deferred update. Okay, immediate and deferred update.